everyone, and welcome to day 2 of lesson 11.3. Today we are going to talk about volume of cones. Similar to our pyramids, volume of cones require us to take 1/3 the area of the base times the height. Now, similar to cylinders, that area of the base is always the area of a circle, so we can just kind of quickly substitute in pi r squared h for that area of the base. And then times that height. And again, it's always 1/3 of that value. So either calculate the area of pi r squared h divided by 3, or you can multiply it by 1/3. So when we are looking to find the volume of our cone rounded to the nearest tenths, we would take 1/3 times pi times our radius value, which here is 3, squared times the height of the cone. So again, when you type this in, you could take either pi times the radius squared times the height, and then divide that value by 3. Or from the get-go, you can just type in 1 divided by 3 times pi times the radius squared times that height, and get the 18.8 either way. In our second example, we are given verbally, in words, what's happening as opposed to a picture. This time we're given a diameter, which is 6 inches. So we know the radius is 3, height is 5, and the volume then we would want to calculate doing 1/3 times pi times our radius squared times our height. So 1/3 times pi times that radius value of 3 squared times the overall height of 5. We get about 47.1 this time. Now, a reminder, this is for rounding your answers. Had we asked for answers in exact, you just would not type the pi in the calculator, put it with your final answer. There are 2 examples for you to try. The first giving you the radius and the height, and then you try number 2 giving you this picture. Find the volume of each and round to the nearest tenths. All right, down below in example 3, we are actually being given this time the volume, and we are being asked to work backwards to find the height given a radius value of 3. So again, we know our formula is 1/3 times pi times the radius squared times the height. So this time we can plug in these values, the first being our volume, which is 66, and then the second being our radius value of 3. And our goal is to get the h value by itself. So to undo this 1/3, step 1, I like to just multiply both sides by 3, so it cancels out the 1/3, and then 66 times 3 is 198. Now that is equal to pi times our radius squared, so 3 squared is 9, times our height, and then we have to divide over both the 9, so that we get 22, and then we still have pi left to divide over, so we get an approximate height of about 7.00, which we can just round up to be 7. The next one in example 4 is asking us to find the radius. This time we are being given a volume of 8143 and then the height of 30. So this one's going to look a little different because when we plug in our volume this time, we know the volume equals 1/3 times pi times the radius squared that we don't know times 30. So again, I like to start this off by multiplying both sides by 3 because that cancels out the 1/3. So 3 times 8143 is 24,429. And that equals pi times my radius squared times 30. And again, our goal is to get the radius by itself. So next step, I'm going to divide both sides by 30. So I have on the left-hand side now 814.3. And then I need to still get the radius by itself. So I'm going to divide by pi. And since pi doesn't cancel out, I'll just approximate 814 divided by 3 is about 259.1997. So this is my radius value squared. So I do have one final step to get my final answer for the radius is I have to square root the 259. So I'm going to be a little lazy. I'm going to take second square root, and then I'm going to hit second answer. Oops, second, the negative to plug in that previous answer. I get about 16.1 as the value of my radius. On the back, there is a U try. This time you are given the volume and the radius, and you are looking for the height. Work backwards to solve. Right. In example 5, we are looking to find the volume of our composite figure. So notice our composite figure is made up of two separate figures this time, a cylinder with a cone stacked on top. So first things first, we are going to find the volume of our cone. So 1/3 times pi times our radius squared. Well, if we notice down here, they are giving us the diameter is 16, which means our radius for both the cylinder and the cone is going to be 8. Now the height specific to the cone is 5. And we're going to round to the nearest tenth on this one, that we have 1/3 times pi times that radius value of 8 squared times the height of our cone, so 335.1. Next, we want to find the volume of the cylinder. This cylinder is pi times the radius value squared times the height of the cylinder. So be careful, the cylinder's height is different than the height of the cone. The cylinder is only 10 units tall. So pi times the radius squared times the height, and that gives us a value of 2010.6. Now, last but not least, we are going to find the total by adding our two together. So 335.1 plus 2010.6. We get a total of 2,345.7 cubic meters. All right, there is now one for you to try. In number 4, you are finding the total volume of that composite. All right, last example, in example 6, we have a paper cup that is a cone, and it says it measures 40 millimeters high and 40 millimeters across. So that means our height is 40 millimeters, and then our diameter, if we talk about all the way across, is also 40 millimeters, which means our overall radius is only 20 millimeters. So this time, if we want to drink 40,000 cubic millimeters of water, how many times are we going to need to fill up the cup? Well, let's think about the total volume our cup holds to begin with. So that's 1/3 times pi times the radius squared times the height. So if we type that in, we get a total of 1,755.2. And again, that's the volume for just one cup. Well, if I need to drink 40,000 millimeters, cubic millimeters, I'm going to divide my value here by my answer to figure out how many times I will need to fill up my cup. So in this case, I'm going to take 40,000 divided by 16,755.2, and I'm going to have to make 2.3 trips. Or we tend to like to round these up for a total of 3 trips or 3 times to fill this up to the next whole number. All right, our last one, you are going to help figure out how many trips will it take to haul away dirt if I'm digging a hole that is cone-shaped, measuring 3 feet high, 4 feet across. And again, how many trips will it take me if each time I can only move 3 feet of dirt? Thanks everyone for watching. We'll work more with these in class.